Good afternoon. Since my time is limited now, I'll just present this in a different way. Let me tell you, not different from what's going on here, but a different approach to presentation of the paper. We have a regulation, and regulation has to be implemented. It's about ballast water. We take ballast water on board the ship, we treat it, we discharge it. It's going to happen in Bangladesh. The ship arrives in Bangladesh, and before discharging the ballast water, the Port Authority wants to know whether it complies with IMO's regulation or not. IMO has developed two guidelines, G8 and G2. G8 is to develop the system in a way that it's going to be harmless to the environment to discharge the ballast water. G2 tells the port authorities and the state control to how to sample the ballast water from the tanks to make sure it complies with the IMO's regulations, G2. There's a big problem here, and I'm warning whoever is from Singapore Port Authority or whether you have connections over there. There's a huge problem with the enforceability of the G2, because G2 has scientific issues associated with G8. This means your ships, the ships you are building, could go to a European port and get arrested. The captain can go to jail, or the ships coming to your country can take a sample and then say your ballast water does not comply with the regulation of IMO, and then you can arrest the ship whilst the ship is not guilty, and then you have to pay hundreds of thousands of dollars fine to the ship. So this paper explains what the problems are, and I go through it very quickly because I promised the chairman I'm going to do 12 minutes. I show the regulations. This is the part of the convention, so you can read it in my paper. This sampling is one part of it. This is the regulation. When you take a sample, there are two types of species in the water. One we call them zooplankton, the other one we call them phytoplankton. I don't think there's any marine biologists in here. Zooplanktons are animals, phytoplanktons are trees. Animals in the water are called zooplankton, trees or plants in the water are called phytoplankton. Zooplanktons are bigger, there should be less than 10 in one ton to comply with the regulation. Phytoplanktons are smaller, and there should be 10 in every milliliter. So we can see there are 2 tens. So if a ship comes to Bangladesh, you take a sample, there are more than 10 zooplankton in 1 ton, and there are more than 10 phytoplankton in 1 milliliter, the ship is guilty, and you can arrest the ship. This is the regulation. This is how the G8, which is for the testing, is advising people to do. You can read about it. This is how systems get type approval. So when you design this system, the system is going to go through type approval with classification. This is in the paper. One of the elements with G2 is that when you take a sample from the water, it must be representative of the whole discharge. The word whole discharge is there. So you can't go in the tank and take a sample and say you're guilty. Your sampling must be representative of the whole discharge of the ship. 1,000 tons, 5,000 tons, 50,000 tons. It must be representative of the whole sample. We have a set of environmental standards in the UK, and we have to follow those because this is an environmental issue. And they give us guidelines how to take a sample, and what is the meaning of the representative sample from the whole discharge. If you're interested, you can read that. But they are also making some other issues associated with that sampling. I don't want to go into the details of that because it is a bit scientific. But the whole issue with this is when you want to take a sample, it is subject to a lot of variability. On board the ship, this is the phytoplankton, this is the phytoplankton, this is the zooplankton, these are zooplankton, and these are zooplankton. So these are the ones who are larger organisms, these are the ones which are the smaller ones. You can also find a fish in your ballast tank. This is my own picture when I went on board the tanker in Dubai. Inside the ship, the structure of the ballast tanks are different, type of the ships are different, the size of the tanks are different, and the pumping system is different. So these all add to uncertainty in taking samples from the tanks. Waters around the world are different. Different colors means the the species in the water are different. The zooplankton found here are not found in here, and vice versa. So every color represents another set of variability. So if a ship moves from the Middle East to Singapore, or it goes from Middle East to North America, it carries different species to different places. Mathematically, we have to come to a solution. What is the representative sampling? We make some assumptions. And in those assumptions, we said every ton of ballast water is one population, and every ballast tank every ship would have 8 ballast tanks, which is not right, but we have less than more. But we have to start from somewhere. In my presentation, I have only one equation. This is the equation that the statisticians use. And as Trevor agreed with me, is an expression that says liars, damn liars, and statisticians. So statisticians are worse than damn liars. So with the numbers, we can do whatever we want to do. But this is the most reliable equation which we can allocate representativeness. This is your ballast tank. I divided it into 3 sections, top, bottom, and the middle, and I divided it into 8 tanks afterwards. And each one of them is divided into 3 sections because the species here, and the species there, and the species there are different. I can further cut them into more pieces and then make it 27. Cut the longest story short, if you want to discharge 3,000 tons, if you want to discharge 3 tons, if you want to have representative samples, you have to sample 3 tons. If you want to discharge 1,000 tons, if you want to have a representative sample, you have to sample 905 tons to be 95% sure what you take a sample is representative. If you want to discharge 50,000 tons, you have to sample 8,000 tons of water. So just imagine taking 1 ton of sample takes 25 minutes. So if you want to take 8,000 tons, the ship in your water is going to be there probably for 3.5 months until your sampling is finished. So this is almost impossible. So that is the problem with IMO's regulation, that they are asking you to do something which is practically not possible and statistically wrong. You arrest the ship, and you take 5 samples and take it to the port, the ship can sue you and ask for demurrage. And that is a hefty fine. So do you want to stop the ship to take 8,000 samples? Probably not, because that's going to cost you a lot more. This is the same data in the diagram form, and then I'm just referring to the maritime law because we work with a few lawyers and talking about what are the implications, and then you can arrest the chief engineer, you can arrest the captain,